Punchdown tool. Think of the punchdown tool as the heavy-duty anchor of the entire physical network. While the crimper we discussed earlier is used to create the male ends of a cable, the plastic plugs that go directly into a laptop or a switch, the punchdown tool is used exclusively to create the female ends. It is the specialized mechanical instrument used to permanently terminate heavy copper wires into the back of a server room patch panel or a wall-mounted keystone jack. If you are wiring an entire office building, this is the tool you will have in your hand for hours on end, permanently locking the digital highways into the walls. The anatomy of the tool: spring-loaded precision. At first glance, a punchdown tool looks like a thick, heavy screwdriver, but the mechanics inside are vastly different. The handle contains a powerful, adjustable spring mechanism. At the tip of the tool is a specialized, interchangeable metal blade. The blade is not designed like a knife. Instead, it has a distinct U-shape with two very different edges. One side of the blade is flat and blunt. The other side is sharp and angled for cutting. When you press the tool down onto a wire with significant force, the spring inside builds up tension until it suddenly releases with a loud, aggressive pop. This mechanical strike drives the wire perfectly into its slot with the exact mathematical force required to make a permanent connection. The target, the IDC block. To understand how the tool works, you must understand what you are punching the wire into. You are never punching into a flat piece of metal. You are driving the wire into an IDC, or insulation displacement connector. An IDC is a microscopic set of V-shaped metal blades hidden inside the plastic housing of a patch panel or a wall jack. When you lay the tiny, color-coded copper wire over the V-shaped slot and strike it with the punchdown tool, the tool forces the wire deep into the V. The sharp metal blades of the IDC slice cleanly through the wire's colored plastic insulation and bite directly into the solid copper core. Just like with the crimper, you do not ever strip the tiny individual wires. The block itself does the stripping as the tool forces the wire down. The two blocks, 110 versus 66. In the field, you will encounter two vastly different types of punchdown blocks, and you must use the correct blade for each. The modern standard is the 110 block, or 110 block. This is exclusively used for high-speed digital data. When you look at the back of a Category 6 patch panel in a server rack, you are looking at a row of 110 blocks. The metal blades are designed specifically to handle the thick, solid-core copper wires used for gigabit internet. The older standard is the 66 block, or 66 block. You will primarily find these bolted to the plywood backboards of old telecommunications closets. They were designed decades ago strictly for analog voice and telephone lines. They are much larger, visually resembling rows of metal teeth. If you attempt to punch a modern data cable into a 66 block, the metal teeth are too wide and will not create the tight seal required for high-frequency digital data. The golden rule, the cutting edge. The most critical operational rule of the punchdown tool is the orientation of the blade. This is the #1 mistake made during physical network installations. As mentioned, the blade has a cutting side and a blunt side. When you lay the wire across the jack, there is a piece of the wire that goes down into the metal connection, and a tiny tail of excess wire that hangs out the back. You must always hold the tool so that the cutting edge faces the outside of the jack. When the spring releases and the tool pops, the blunt side pushes the wire deep into the metal connection, while the sharp side acts like a microscopic guillotine, instantly snipping off the excess tail of the wire flush with the plastic. If you accidentally hold the tool backward, the sharp blade will sever the active wire leading back to the server, and the useless tail will be permanently punched into the jack. You will have to pull the ruined wire out and start completely over. Solid versus stranded copper. Finally, it is vital to understand the physics of the wire itself. The punchdown tool is designed strictly for solid-core copper wire. This is the stiff, heavy cable that you pull through the ceilings and walls of a building. when you punch solid core wire into an IDC. The metal V-blades bite into it flawlessly. If you attempt to use a punchdown tool on a standard, flexible patch cable, which is made of dozens of microscopic, fragile copper strands, the V-blades will simply crush and break the strands. The connection will fail almost instantly. By mastering the heavy, mechanical pop of the punchdown tool, you gain the ability to physically lock the high-speed infrastructure of a building into place, ensuring the data has a solid, permanent path to travel before it ever reaches a switch.